All right, everyone, let's talk SWE 4303. This is your deep dive into Assessment 2, the big one. We're going to break down everything you need to know, piece by piece, so you can absolutely nail it. Let's jump right in.
Okay, so first things first, let's get our heads around the shift from Assessment 1 to Assessment 2. Think about it like this. Assessment 1 was you being the architect. You drew up the plans, you made the blueprint, it was all theoretical, right? Focusing on those first two learning outcomes. But now we're the construction crew. Assessment 2 is the build. You're taking those plans and making them real. It's all practical, hands-on, and it's where we tackle learning outcomes 3 and 4.
And you really, really want to pay attention to this one. Why? Check out the weighting. Assessment 1 was a decent chunk at 40%, but Assessment 2? That's a whopping 60% of your entire module grade. So let's be real, this is the big one. This is where you have to show you can walk the walk, not just talk the talk. Nailing this portfolio is absolutely crucial for your final grade.
Okay, so here's our roadmap. We'll quickly recap that blueprint to build idea, then we'll break down Task 1, the automation script. After that, we'll tackle Task 2, the sharing solution. Then we'll cover Task 3, the demonstration. And finally, we'll go over the rules you have to follow and have a serious talk about AI. Let's do it.
First up, Task 1, the automation script. This one's worth 30 marks, and it's where you get to roll up your sleeves and do some real coding. We're talking Python. You're going to build a tool that automates some basic but super important OS maintenance. It's time to write some code that has a real-world purpose.
So what even is OS automation? Well, here's a simple way to think about it. Imagine you have to do the same boring computer tasks every single day. Moving files, checking how much memory you're using. It's a drag, right? Automation is about writing a script, in our case with Python, to do all that for you. It's a foundational skill for anyone who wants to work in computing infrastructure. It's about being smart and efficient.
So what does this script actually need to do? Well, think of this as your recipe for success. There are 5 core functions, 5 things your code must accomplish. First, you'll need to use some specific Python modules, like OS, Shootle, and PSUtl. Second, your script has to create a new folder called System Maintenance. Third, it needs to find and move systemlog.txt into that new folder. Fourth, it's got to grab 5 quick samples of your CPU and memory usage. And finally, it writes those samples into a brand new file, maintenancelog.txt. Tick off all 5 of these and you are golden for this task.
Now, this is super important. You don't just hand in the Python script and call it a day. No way. You have to submit 3 things for this task. First, obviously, the systemautomation.py file itself. Second, you need to provide the proof that it works. That means screenshots showing the console output, the contents of your maintenance log.txt, and a shot of the system maintenance folder that you created. And third, a written explanation, around 850 words, where you walk us through your code and reflect on the process. It's the code, the proof, and the explanation. All right, let's switch gears. We're moving from hands-on coding to more of a system design mindset for Task 2, the sharing solution. This is another big one, also worth 30 marks. Here, you're not writing code. You're designing a system to fix a very common business problem. So, what's the problem we're trying to solve here? Imagine a small office where everyone just shares files directly from their own computer. It's a total mess, right? You've got different versions of the same file floating around, nobody knows which one is the latest, and if someone's laptop dies, well, poof, those files might be gone forever. The whole point of this task is to fix that chaos by proposing a move to a centralized system. For this task, you're writing a report, and here's exactly what needs to be in it. You need to explain how a central server works for clients. You have to talk about the big benefits, things like availability, reliability, and data integrity. You'll also need to suggest a real cloud solution, something like Google Drive or OneDrive. And of course, you can't forget security, so you need to identify at least one basic security measure. You'll also include a simple, clean, labeled diagram of how it all fits together, and wrap it all up in about 850 words with proper Harvard referencing. This is all about clear communication and good design.
And that brings us to the final piece of the puzzle. Task 3, the demonstration. This is for the last 25 marks, and it's your show and tell moment. This is where you bring everything together and prove you know your stuff live.
Okay, listen up, because this is important. You get 15 minutes. That's it. It's a hard limit. What does that mean for you? It means you have to practice. You can't just wing it. Run through your demonstration, time yourself, know exactly what you're going to say and show. Preparation is everything here.
So where do the points come from in this demo? It's split pretty evenly. You get 10 marks for showing us your Python script from task 1 actually running and doing what it's supposed to. You get another 10 marks for clearly explaining the client-server ideas from your task 2 report. And the last 5 marks are for your overall technical know-how, how well you answer questions and explain your thinking. So it's half practical, half theoretical.
All right, let's talk about the rules of the game. This is the stuff you absolutely cannot afford to get wrong. Paying attention to these details ensures all your hard work actually counts.
Okay, screenshot this, write it down, do whatever you need to do. The due date is week 15. The format is simple, MS Word for your written parts and a .py file for your script. Your Turnitin score must be under 20%. That's a big one. And be aware there is a late penalty of 10 marks if you're within that first 7-day window. Don't let these simple things trip you up.
Okay, and before we finish, we need to have a very serious conversation. This is about generative AI and academic integrity.
Let's be absolutely 100% clear. For this assessment, using generative AI tools to write your code or your report is strictly forbidden. This is a Category A assessment, which means you are not permitted to use GAI for any content generation. The university policy is simple. If you submit AI-generated content and pass it off as your own work, it will be investigated as academic misconduct. There's no gray area here.
And look, there's a really good reason for this rule. It's not just to make your lives harder, I promise. The whole point of this assessment, the reason it exists, is to test your ability to solve these problems and write this code. The learning outcomes are designed to measure what you can do. If you use AI, you're not learning and you're not meeting the requirements of the module. It's that simple.
So there it is. We've gone from the blueprint to the build. You know what you need to do for each task, you know the rules, and you know what's expected. This is your chance to really show what you can do, to take the theory and create something that actually works. So the only question left is, are you ready to build?